Section 2.1 is on relations and functions. You'll recall from Algebra 1 that a relation is just a set of ordered pairs. However, a function is a relation in which each element of the domain, that is the x's, is paired with exactly one element of the range, that is the y's. In other words, each x goes to only one y. So there are different types of functions. First one we're going to talk about is called a one-to-one function, and it has no repeated x's and no repeated y's. Each x is paired with exactly one y. An onto function has no repeated x's. Repeated y's are okay, but all of the y's are used, so all of the elements of the range are actually used. And a function is both one-to-one and onto if there are no repeated x's or y's and all of the y's are used. Let's take a look at a couple examples here right out of the textbook. It says state the domain and range of each relation, then determine whether the relation is a function. And if it is a function, determine if it is one-to-one, onto, both, or neither. So in example number 1 here, we have a mapping, and I'll go ahead and put the answers down here. Our domain, remember we write that as a set, are the elements in the first bubble here. So -2, 5, and 6. The range are the elements in the second bubble, -8, 1, and 3. And yes, this is indeed a function, and I like to abbreviate function FCN. It is a function because no x goes to two different y's. And this is actually both one-to-one and onto. And it is onto. It's one-to-one because each x is paired up with exactly one y, and it's onto because all of the y's are used. Example number 2 here, this set of pairs, ordered pairs that are graphed. The domain is going to be all of the x coordinates, so -2, 1, and 4. And the range is all of the y coordinates, so that's going to be 3. Well, let's see, let's start at the bottom and work our way up. So -1, 2, 3, and 5. And this is actually not a function because notice that in this ordered pair, go ahead and mark that in pink here. In this ordered pair right here, I have x equals 1, and in this ordered pair here, I also have x equals 1. So this is not a function. And since it's not a function, it can't be one-to-one or onto. And then example number 3 here, okay, my domain is my set of x's, -2, 1, 4, and 8. My range is my set of y's, -4, -2, and 6. And this is indeed a function because none of the x's repeat. And this function is not one-to-one because you'll notice -2 goes to -4 and 1 also goes to -4. But it is onto because all of the y's are used and it's okay for y's to repeat. A discrete relation is a relation that's graphed as a set of dots or unconnected points, like this first example here. Notice it's just a bunch of dots on the graph. A continuous relation is graphed as a line or a smooth, uninterrupted curve. So something like this one right here. So the way I remember it is discrete has dots and a continuous is a curve. And the interesting thing about a continuous relation is the domain must have an infinite number of elements. Notice that this keeps going on forever, so x can equal anything. And you'll probably also remember this from Algebra 1, the vertical line test. It's a way to determine if the graph of a relation is a function. And that is, if a vertical line intersects the graph at only one place at a time, then it is a function. If that vertical line intersects it in 2 places at one time, then it is not a function. So let's take a look at a couple examples here. Graph each equation, determine the domain and range, and determine whether the function is one-to-one, onto, or both, and then state whether it is discrete or continuous. So this one obviously is a line, y equals 5x plus 4. And just to remind you how we graph, we're going to start with the y-intercept of 4. And my slope is 5, so that means I'm going to go up 5 and right 1. Or I'm going to go down 5 and left 1. Something like that. And since it is a line, I will connect the dots. Okay. So in this, since this is a line, my domain is all real numbers. And that just means that x can be anything. My range is also all real numbers. Okay. And this is a function because it would pass the vertical line test. And it is actually both one-to-one and onto. Because each x is paired with exactly one y. And because this is not a set of dots, it's actually a continuous function. Okay, let's take a look at another example here. Here we have the equation y equals 3x squared, and you probably recognize this as a parabola. Since I can't just graph it as easily as I did the last one, I think I'm going to make a simple little table of values here. And I think, let's try -2, -1, 0, 1, and 2, and I think 2 is going to go off the graph. So if x is either 2 or -2, squared is going to give me, oh no, that'll actually fit. So 2 squared is 4, so that's going to give me a 12 for either of those. 1 squared is going to give me a 3, and 0 will give me a 0. So yes, you can do this on your calculator, but I want you to be able to do it by making a table of values. And 12 is actually going to go off the graph, so I'll put it up here. So it's a parabola that is very tightly up against the positive y-axis. Okay, and the domain for this, what can x be? X can be any real number. And the range, so taking a look at this graph, you can see that y really can't be anything that's less than 0, because there are no values of y down below the vertex right here. And also by looking at the table, you can kind of figure out what's going to happen is as my x's get smaller, my y's are going to get bigger, and as my x's get bigger, my y's are also going to get bigger, and my smallest y is a 0. So my range is the set of all y such that y is greater than or equal to 0. Okay, this function is neither one-to-one nor onto. And here's why. So it's not one-to-one because notice that the x is paired up with, or in other words, y's repeat. So you can't have any repeating x's or y's in order for it to be one-to-one. And it's not onto because there's a whole range of y values down here that cannot be used. So y has to be greater than or equal to 0, so y cannot be -1. So it can't be onto. And then this is also a continuous function. Okay, and our last couple things here, and you should remember this from Algebra 1 as well. We talked about an independent variable. That's generally the x-coordinate. And those are the values that you choose to put into the function. Often in physics or in other branches of science, it's time. Time is an independent variable. The dependent variable is generally the y. And it's called the dependent variable because its value depends on whatever the value of x is. Function notation, we did this in Algebra 1, f of x. It's just a fancy way to say y, and it's an expression for the dependent variable that shows us what the independent variable is. So f of x is the dependent variable, x is the independent variable, and it shows us that we're actually putting x into the function. And to wrap up here, we'll take a look at a couple examples here. So given f of x equals negative x squared plus 3, we need to find each value. So I'm going to start with, I'll just go ahead and do this, f of x equals negative x squared plus 3. And remember what we do is we take this 5 and we plug it into here for x. It's just a simple substitution. So f of 5 is equal to negative 5 squared plus 3. So that's going to be negative. And notice it's not a negative x that's squared. It's x squared with a negative 1 in front. So that's going to be a negative 25 plus 3, or f of 5 is equal to negative 22. So for f of 3, I'm going to do the same thing. I'm sorry, f of negative 3, I'm going to take a negative 3 and plug it into there. So I'll have a negative 3 squared plus 3. That's going to give me a negative, and negative 3 squared is 9 plus 3, or, oops, sorry about that. f of negative 3 is equal to negative 6. So in this lesson, we looked at what makes something a function, what makes it a continuous function, a discrete function, one-to-one, onto,